Well, I could not have asked for a better platform to talk on, especially after these two brilliant speakers. So hello, my name is Tom Bryan, and I am very fortunate to be a student of Dr. Kathy Middlecamp and work very closely with the organizers of this event today, the Office of Sustainability, and I'm lucky enough to work with the wonderful Union Dining Services, the creators of our lunch today, and a wonderful organization. I'd like to share with you what happened when we fed 100 undergraduates a meal and told them to carbon footprint it. Step one, well, we had to figure out the carbon footprints for ourselves. Here I'm standing behind the counter of Ginger Root, right downstairs, and the creators of our lunch today. It is a very popular campus eatery, and I owe a lot to the Ginger Root staff and the Union Dining Services staff for letting me come behind the counter and ask prying questions like, how much does your shrimp weigh? And how many meals have these black bowls seen, and how many of them fit in your dishwasher? And even better yet, they let me into their pantry, and even better yet, they gave me a copy of their secret sesame sauce recipe. My task now was to figure out where all this food comes from, how much energy it used to get here, and how much waste was created along the way. So I went straight to the source, V. Marchese of Milwaukee and Martin Brothers of Cedar Falls, Iowa. V. Marchese supplies all the fresh fruit and vegetables, and Martin Brothers supplies everything else. I'm going to take a breath, and let's look at some photos. That is a table full of fresh-cut pineapple. When is lunch? Enter a generic food supply chain. Producers transport to processors, who transport to distributors, who then transport to retailers, who then someone cooks it, and usually, like Lydia said, there is some waste. So I felt compelled to turn it into an acronym because it is a hideous process, as Mike said, and it is an equally hideous acronym. So if you'd like to join me, 2 letters at a time, say it with me. PIT, PIT, DIT, flourish on the end, require. But the brutal fact of the matter is that energy is used and waste is created at every single box on this. And in the class that I help teach with Dr. Kathy Middlecamp, we teach students to uncover how consumer choices have incredible upstream consequences. And in this case, we teach them to see the invisible, represented by purple clouds. These represent CO2, other greenhouse gas emissions, and we only have, as consumers, we only have a small part to play in this, but we have a huge impact. How to tell how big these purple clouds are relative to one another? Well, we need some data. And here is the data just for 1 kilo of broccoli. And this is where the folks at Ginger Root and the folks at V. Marchese and Martin Brothers really shined. They provided most of this data, and they know their industry forwards and backwards, and I give credit to them wholeheartedly. What to do with all these data? Well, enter Food Carbon Scope, a customizable algorithm-based software tool for carbon footprinting in the food and beverage industry. I struck gold. And thank you to the Office of Sustainability SIRE Grant Program for making the use of this software program possible. So let's turn that previous slide, that hideously complex previous slide, into a graph. Just for broccoli here, so we have a kilogram of broccoli, and going through the PIT, PIT, DIT, require, up on the y-axis, carbon footprint on the x-axis. And at least for broccoli, from these data, we can see that it's not PIT, PIT, DIT, require, it's more like PIT, PIT, DIT, require. Which is contrary to the belief that food miles has the most impact, and that food miles, you should really pay attention to food miles. So how does broccoli stack up to other ingredients? Well, let's take a look. Animal proteins and rice, as has been foreshadowed, top the menu of Ginger Root as the top 6, and broccoli is much further down the list. When I have more than 2 seconds, I can tell you about carbon footprint per gram of food rather than per serving. And the plot thickens when calories are concerned. And there's a whole host of nutritional information that these data can be normalized to, but the work of Mike Berners-Lee and others is absolutely brilliant with this. And really, when you're considering nutrition, you have to consider the entire diet. And so for this case study, we looked at 1 meal, So nutrition, you can't conclude a lot from this. But what happens when undergraduates on this campus eat a meal and then carbon footprint it with these data? Does beef make them nauseous? So here's screen captures of the laboratory activities, and in exactly 42 days, about 100 UW-Madison undergraduates will have gone through these lab activities and eaten a meal downstairs at Ginger Root, and then they carbon footprint it. Every student, a different meal. Every student, a different carbon footprint. So we, the teaching staff of Environmental Science 126, have conversations with our students about food carbon. When we have conversations about food carbon footprints, we use the students' very own data to talk about it. They eat the meal, they carbon footprint it, then we all interpret the data together, and we all find the stories behind the numbers. For example, Henry was a student in our class last spring and has given me permission to show off his meal and his data. He had broccoli, white rice, and chicken. And here is his data. White rice tops the list, with chicken followed closely. And the students inevitably call this to our attention. I thought you said meat was bad. So we look at the stories behind the number, and story number one for why white rice tops the list is the more you eat, the more impact you have. Not to discourage anyone from eating, of course, but the serving size of white rice is indeed larger. So per serving, it should have a larger footprint. Per gram, different story. But the students are still inquisitive. Their lines of inquiry are generated by themselves, and they say, what? What's the story behind this? And as Mike brilliantly alluded to before, how the food is grown affects it. So if we look at the specific data on rice, that if we see it's continuously flooded, if it's grown its whole life cycle under flood, it has a carbon footprint of 3.2. If you flood it a little less, it drops dramatically down to 2.3. But you can see how the teaching and learning opportunities are abound when students want to lift the curtain and see the stories behind the numbers. And that is incredibly satisfying as an instructor. I'll let the students talk now for a little bit, the students from last spring, and here are some anonymous student quotes. Don't spoil this for our students, but here are the two of the biggest punchlines that we talk about. When you're making choices at Ginger Root, vegetables almost always win from a carbon footprint perspective, and local doesn't always win from a carbon footprint perspective. When students avail themselves of the bird's eye view and the life cycle perspective, conversations about a kilo of broccoli from Ginger Root quickly turn global and hideously complex, which as an instructor is the most satisfying thing ever. And ultimately, we teach students to see the invisible, to see the nitrous oxide rising out of the nitrous oxide and methane rising out of the rice paddy, and the methane emerging from the cow's ends. The real challenge is that global impacts, especially for your dietary choices, are often invisible, but have huge impacts. Lastly, and most importantly, I'd like to thank the Nelson Institute and the Office of Sustainability for their support and guidance. And huge thank you out to the Wisconsin Union Dining Services for their partnership. I'd like to also thank the folks at Martin Brothers and V. Marchese for welcoming my prying eyes and curiosity into their warehouses. I would also like to thank Mr. Mike Berners-Lee for hopping the pond to be here today and for writing the book that has inspired so much of my work. To my graduate advisor, thank you for everything, and thank you all for being here.